it work? It works. Woohoo! Wow, that's amazing engineering. So yeah, I'd like to start this morning with the exciting topic of platform engineering, right? So I think many of you have been in touch with this topic before. So my name is Bjoern. I'm a chief technologist for Broadcom, and I've been with VMware for the past 15, 16 years now. And I've actually seen a lot of the technologies that have come through over the period of time. And I just want to give you like one slide, and that's it, about Broadcom and some of the components that actually make up the larger infrastructure. So you've probably heard about the company before. So, but just to give you a glimpse, so these are all projects where, and companies and involvements where Broadcom over the past decade has been contributing a lot. So if you look at the top right, Pivotal, for example, was a company that was spun out specifically on developer experience, developer productivity. So it was a lot of effort with the open source Cloud Foundry project, for example, which is still going strong, helping developers realize what they want, and before Kubernetes was a thing. Right, and then we brought in, so we were a founding member as VMware of the Cloud Native Computing Foundation. Projects like Harbor have been originated at VMware back in the day, and today you probably know Velero, you probably know some of the technologies on the screen, but also, and that's something that is personally, I like it very much. I'm super excited for things like Wi-Fi, for example. Wi-Fi standardization is something where Broadcom is deeply involved, but also Ethernet, and there is the Ultra Ethernet Consortium, for example, that is building out Ethernet platforms for high-performance clusters and AI workloads to actually get stuff done, right? So that's just a snapshot, right? So that's I built this slide literally 10 minutes before. So you probably know the brands VMware and Tanzu, right? My focus is on VMware, so that's everything Kubernetes, and Tanzu is very much focused on developer productivity and developer velocity kind of topics. But that's all. That's all the products you will hear from me today. So my focus is on platform engineering 2.0, and let's get right in, right? So where are we today? And that's actually a very exciting point in time. So we did a study, a research, jointly with platformengineering.org. So it's a very comprehensive document. You'll get a link to the printout that you can download. It's a 40-page report that is really having some good points in it. But as of today, 90% of organizations have adopted platform engineering, 76% have a dedicated platform team, and 70% are actually measuring their success, right? And before we dive into anything platform engineering 2.0, I just want to recognize that this is actually a very, very powerful situation, right? So over time, this has actually become a practice that is useful in organizations, that helps, you know, to hide complexity on the lower parts and actually help consumers accelerate their work, right? So just a quick recap, what is platform engineering 1.0? The goal was always to reduce the cognitive load on the developers, right? So how do we make their life easier? Should have been the mantra for all the teams. And one key aspect of this is platform as a product, right? So platform as a product means you treat your underlying platform as a product, you have a roadmap, you have some clear guidance on what's going on, and then you build something that can be used by everyone that wants to consume the platform. And this includes stuff like golden path standardization, right? So making it easy, opinionated, but pre-approved and fully working templates that can be rolled out pretty quickly, which is all about increasing developer experience, happiness, and then the productivity, of course. And then last but not least, shifting left from a security perspective. So doing security earlier, instead of catching something in production, actually trying to catch something as early as possible as part of the development lifecycle, and then building things on top of this, right? So who of you would say you're part of platform engineering or have platform engineering established? So I expect 70% of the hands to go up. No, 90%. So, okay, that's good. Awesome. So again, congratulations. I think we have achieved a lot as an industry, right? So there was a lot of back and forth, and Kubernetes as a developer tool is something that I heard in the early days, and then people realized, well, it's great for self-service and API access to infrastructure, but it's still pretty complex. So we need to take that abstraction leap and actually help developers get stuff done in a different way. So why is platform engineering actually 2.0 actually needed now, right? So what are the limitations and the ceiling of platform engineering 1.0? And this is, let's start with probably the most obvious one on the left-hand side. It's an AI-blind architecture. When platform engineering, DevOps, containers were coming up, there was nothing on what we are seeing today with the hype around AI agents, LLMs, access to GPUs, etc. Everybody was happy with, having a container platform in place and offering container as a service and things on top, right? So that's one of the big shifts. The other one is platform engineering 1.0 was always focused on the developer, right? So it's a very, very narrow focus on one team, but it's actually a multi-people org, right? It's not like you only have developers, you still have others around that haven't really been adopted. And then reactive, not proactive, in a good way, right? This is not about talking bad about things that have been happening in the past. This was all good. So to build golden path, you need to find a way, or you need to look at things that have been going on and then standardize them and get them into a golden path. The challenge is, if you follow too much and too strict the golden path, it might end up as a golden cage, right? So you don't really have an easy way to do innovation because you're always locked down into the standards that can be pretty prescriptive. And then, of course, you have a pretty static platform, if you will, because the ecosystem has grown so dramatically from 50 projects in the CNCF to 200 plus projects today, and there's much more happening at the pace that we are in right now. So the forces that demand platform engineering 2.0 is, first of all, AI-driven coding acceleration. So 90% of the developers use AI tools, right, if they admit it or not. That's a huge, huge number of developers. And they generate twice or up to 10 times as much code as before. So the pipelines and the platform need to support the same velocity. They need to support 2 or 10 times the velocity of stuff, right? So just think about this. The more complex your platform is and your workflows are, this is actually quite some stuff to adopt. Second thing, agentic future. So you need to think about agents that are talking to the platform, where you need applications that actually, or somebody's building an application that actually wants to run agentic work. It needs access to a GPU, for example. Sometimes just a time slice, right? But you need to handle these kind of things as part of the platform. And then FinOps reckoning, right? Great if you do cloud spend once a month, that's all good. But if you look at token costs these days and the availability and the duration on which your tokens are actually working, so people sign up for a 12-month contract, but they burn through the tokens in like the first 3-4 weeks, right? So how do you make sure the FinOps is actually ready for that new level that is happening as well? And we all know 35% of cloud spend is waste, right? So if we translate this over into the AI world, that's going to be really, really challenging. Sovereignty and compliance, we heard it yesterday in the closing keynote, right? It's a big topic. So what's the dependency? What's your technical foundation? How does it look like? And how sovereign can you operate this and have your data sovereign? And the security and compliance topic is a big one that comes into play. And then, of course, the multi-persona enterprise. So you're not just the developer. You always have to worry about other folks as well. So we started out with the DevOps era. It was a little toxic in those days, right? So you build it, you run it, and people needed to worry about all kinds of things that they had no clue about. And then suddenly infrastructure came into scope, and it's like the developer just wants to write code and get it out, right? So then we had Platform 1.0, Golden Path, and then the inflection point, I think, where people started revisiting stuff, where also this work started, was in 2024 and 2025 with AI, sovereignty, but also the supply chain shock, right? So I don't know if you've seen hardware prices recently. It's pretty amazing how the same piece of hardware is suddenly more expensive. So Platform 2.0 is AI native, autonomous, and business aligned. What doesn't change is this whole notion of platform as a product, right? So that remains. So let's take a look at the 5 pillars. And again, I won't be able to go into like all the 5 pillars in detail. I get you to at least to the QR code for the document at the end. So you can download it and take a look at the details yourself. But the 5 pillars are, it needs to be an AI native platform. The multi-persona experience is the second big effort, right? So how do we build this for multiple consumers? Embedded FinOps the security is not just shifting left, but it needs to shift down into the platform, right? That's a complementary move, so you cannot expect the developers to take a look at everything when it comes to the security, for example, of your LLM that is part of the platform or that is part of the organization overall. And then the last one is super exciting because we've always been thinking about build versus buy, but it's actually composable is the next thing, right? So you need to be able to have open interfaces and to connect and disconnect pieces. Instead of deciding, I build everything or I buy everything, right? You need to make a mix of everything and get a realistic version of stuff, right? And so I've seen this so often, so you can say, okay, I do this end-to-end open source and do this all by myself. That's great, right? But you need the team, the commitment also from leadership to actually do it, because open source, just downloading stuff off the internet to run it is not really something that is sustainable for us as an IT industry, right? Or people in the IT industry, because it needs to work out long term. And I don't know if you've heard about Mythos and what's going on in the frontier AI spaces right now. So the security threats are getting tougher and tougher, right? So we're part of the project Glasswing that Anthropic started a few months ago. So we are seeing the outcomes already for, hey, we're not just, it's not a security scanner. Those frontier AI models are not just security scanners. They are actually super useful when you let them scan your source code on the one hand side, but then have a live environment on the other side and say, you know, build me an exploit, right? I don't believe you, I want to see an exploit. And then if you put these two together, so full source code access, and you want them, you want the models to actually generate exploits and proactively show you where vulnerabilities are, then it gets really, really fancy, right? So Mozilla, I mean, you can see the reports online. But if you're in IT and you haven't seen or looked into this space yet, do it, because the industry, the next 12, 18, 24 months, we will see such a wave of updates and patches for systems all over the place. This will be a very, very interesting time because of the vulnerabilities that are being discovered, or the chaining and the attacks that are happening now, because if you set up an open cloud today and you give it a model that is basically doesn't care if it's doing harm or not, it can do very, very bad stuff in a very, very consistent, and it will not sleep, it will not, you know, say, no, I'm tired, I don't have the energy to hack this system anymore. It will just continue going. So again, keep this in mind, and this will be a very, very important aspect. So AI native platform, and there will be three major shifts, right? The first one is supporting AI on the platform. That's number one. So enabling workloads that actually need GPU resources. The second one would be AI agents as platform citizens, right? So AI agents that consume your platform instead of a human clicking through or leveraging your CLIs or your APIs, right? So that's a very important aspect. So that documentation needs to be pretty good and very, very solid, because that's exactly what the agent will use to talk to your platform. And then in the future, right, I'm not saying tomorrow, but in the future, long term, we're talking about AI-powered autonomous platforms, right? Self-healing, self-governing, self-optimizing, so all these things where an agent can do stuff, right? Right now, human in the loop makes a lot of sense, because if the agent decides, well, you know, that database is completely useless, it's only, I haven't seen it being used in 3 months, it's only being used on Christmas. So let's delete it because it's on the cloud bill, it's so expensive. So that's always not a good idea. So that's number one. The second one, multi-persona experience. So as I said, app developer and of course the platform engineer have been the ones that have been accessing the platform in the early days, right, or in the old days. But now we need to enable this also, a live view of the DORA metrics or the FinOps transparency. That's very important for the business leaders to continue to justify why we're doing this, right, and giving like a snapshot of what's going on in the environment. I think this is a very important aspect to connect the value that the platform engineering team and the organization gives into the large organization. So if you can share live metrics, if you can enable a dashboard, even if it's just weekly updated or whatever, it's always, and this is something I'm seeing on a daily basis, right? You need to be able to articulate the value of your operational efforts and the value that you bring into the organization, because again, platform as a product, right? So you're competing with the the hyperscalers, for example, that are telling everybody, hey, you know, this stuff, for example, is so amazing, and if you do this integrated thing here, that's all good, but you as a platform organization say, you know, yes, that's great, but for us, this is actually a bigger picture, and we need to worry about a few things in addition to that, but if you cannot articulate the value, it's very difficult to argue for it, right? So always keep this in mind. Measuring is very important. Then giving access to data scientists, ML engineers, that's another important aspect, right? Many have done this in some shape or form, but it was never a primary audience. And then, of course, the security and compliance teams, policy as code, being able to continuously running compliance checks on the platform. This is going to be crucial going forward. Again, remember me when you see the first big waves coming out for patches in the next couple of months, where people will ask, hey, are we on this version yet? And is there any outlier? Do we have any system left? Because 1 out of 5,000 systems being vulnerable will still keep you vulnerable, because the agent will take one opportunity and then spread internally if possible. And then, of course, API-driven AI agent access to the platform is the other one. Embedded FinOps, so cost as a first-class signal in the platform. So we all know, you know, there is a lot of waste happening on all kinds of infrastructure, right? So there is a report from Cast AI that says 8% CPU, 20% memory, and only 5% GPU utilization of Kubernetes workloads in public cloud. So you can see this is there are ways to optimize this. The developers are typically ignoring cost management. They want to have more control, but if they don't have the tools, the access to the actual live data, it's very difficult to do. So it's a very hard to optimize effort overall. So it needs to be in the platform itself. It needs to be available self-service in the platform. It needs to bubble up there. And then you need to have real-time cost attribution, not something that is done at the end of the month, right, where you take a look at the bills and then match it to the actual teams. And the one in the middle is actually very important. So pre-deployment cost gates. So if you're kicking off a job, for example, for something that needs to be calculated, or an agentic workflow, whatever, you need to estimate the cost. And is that team still eligible for that budget or not, right? Because you might easily eat through the budget within a few days. So you need to have this predictively and actually stop potentially an effort from kicking off before it's running. And then, so this needs to be incorporated as part of the platform as well. And then tokenomics, right? So AI-specific cost is going through the roof. So you need to show back so who is using what, the number of tokens, the GPU time, and then have a policy engine that can actually specify thresholds on a per team basis and also suggest alternatives, right? So it might be cheaper to run it on a different model, or to run it on a self-hosted model, or whatever, right? So this will be something very interesting. And then autonomous janitor jobs, resizing agents, self-service, or self-healing, self-cleanup kind of agents. That's going to be stuff for the future. Security shifts down. So as I said, security shift left. The promises were all very good, right? So developers own the security. The pipeline scan catches all the issues, and then you have the static and dynamic scan. So it's all great. Reality is, well, it's a lot of cognitive overload for the developers. Because they need to worry about all kinds of things. Then you have new standards that pop up, new regulations that are coming up. So you have Cyber Resilience Act, you have all kinds of industry-specific topics. It's not something that developers can really keep in mind and be responsible for, so it needs to be somehow taken off them, right? And then even though this is all there, you still find most vulnerabilities in production, right? They are not found or caught before that. You have a lot of false positives because the scanning is too, so you have 15 tools scanning all the code base. And you have all kinds of alerts popping up, but nobody, it's a lot of fatigue, einfach alert fatigue, where people go like, is it really true? Nah, that's a false positive again. And then remediation cycles, once it's in production, it takes some time to get it out again. So the idea of shift down is actually embed security deep in the platform, in the infrastructure, make it invisible and immutable from a security perspective, but also do automate remediation for known patterns, the CVEs, and then having policy as code, as I mentioned, is another topic. So keep it very simple, but offer it as part of the platform, so you cannot violate the policies. and you have actually a very strong posture, while shift left stays, right? So security scans in CI/CD are still very important. Security training for developers are still very important, but we can take some of the cognitive load off the developers and move on. So, and there's a new frontier. So AI security challenges that I haven't mentioned yet and that are not part of the concerns today will continue to come up, right? So shadow AI sprawl. Everybody's using some kind of AI system. If your token budget has been exceeded, then suddenly people start copy and pasting things into public models where they probably shouldn't end up. Then you have prompt injection, so you have a system where people, where consumers are actually talking through an application with an LLM, and then suddenly they can inject, good morning, they can inject stuff through a prompt. Model poisoning, where your model's coming from, is that safe or not, right? And then inference data leaks is another topic, right? So personal identifiable information or intellectual property being exposed through the response that the model is giving. All very difficult, so you need a model registry governance, you need data isolation, prompt security, and then also an inference audit and an audit trail, so everything that is being shared is actually captured somewhere, so you can come back to it. And then composable by design, so again, I need to quicken up a little bit. So CNCF conformant and or certified options are a very big building block, but being able to swap out depending on where you need to be continues to be very important, right? So looking into open interfaces and open interchangeable capabilities, that's a very important thing, because there will be new projects, right? We're not at the end of this. We're just at the starting point. The platforms and the systems and the projects will get better, and you will want to bring in the best one for your use case when you want it, right? So we have a bunch of ideas about this, so capability layers, so infrastructure integration capabilities, orchestration and experience, right? So that's a way to structure this, and then looking into the modular services and tools as they come. So I'll skip this one here. As a wrap-up, again, those are the 5 pillars, right, that we're talking about here in this framework. So what's next? As I mentioned, a business case for your platform engineering 2.0 is very important. So talk about why it matters to your organization, make this transparent, and then show back what's actually going on. But setting out a 12-month AI native platform milestone is something super important. So taking a look at, hey, if we don't have an AI-ready platform today, we need to work on this now, and the goal should be get it established in the next 12 months. And for you as the platform engineers, for example, API first, composable architecture, embed security and FinOps into the platform layer. So these are the important things. So as I mentioned, you can download the report. So that's the QR code you want to scan. And if you want access to this, this takes you to the platformengineering.org website. And so this was all commissioned through Weave Intelligence. I think they are from Berlin, if I remember correctly. So it's a pretty cool report. Everybody done with the QR codes? 3, 2, 1. Excellent. So thank you very much. And I'm 10 seconds over. Thank you so much.